Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. Here's step one. Here's step two and here's step three. And your challenge is to predict how many pieces this circle is cut into in step four. If you can do that, can you predict the number of pieces in step 43? And can you write an equation that could be used to predict the number of pieces in any step at all? That's the challenge. If you'd like to accept it, pause the video and see what you can do. All right, so in step one, it's a little funny. We don't even have a circle, so the number of pieces here is just 0. And then let's see, in 2, this is cut into 4 pieces. And in step 3, what have we got? 1, 2, 3, 4, 5, 6. Yeah, it looks like 12 pieces. So it seems like it's growing pretty rapidly. But how do we predict step 4? I'm not really getting a lot of good intuition just from looking at this. Well, you know what? When in doubt, let's try analyzing the numbers. So I'll make a chart with the step number and the number of pieces. And we'll see what the numbers tell us. It's going to be a little hard if this is quadratic, which I'm expecting that it'll be quadratic because the numbers are growing so rapidly. Well, we'll cross that bridge when we get to it. So in step, not in step 0, in step 1 there are 0, in step 2 there are 4, and in step 3 there are 12. So it goes up by 4, and then it goes up by 8. So does that mean the amount it's going up is doubling every time, or the amount it's going up is increasing by 4? Let's see what would happen if the amount it's going up is increasing by 4. So 8 plus 4 would be 12. So in step 4, we'd have 24 here. And then if we do our second set of differences, 8 minus 4 would be 4, and 12 minus 8 would be 4. And that would lend us to think that this is quadratic. And that's my hunch here, that this is probably quadratic. Maybe we would need one more step given to us to be sure, but I think I'm going to go down this path and say that there are 24 pieces in step 4. Now, coming up with an equation here is pretty difficult, and there's not a lot to go on from the visual that we have. This 4, though, tells us we've got a constant in the difference of the differences, so we know an x squared is there. And this 4 is if you divide it by 2, you get the coefficient. So we have a 2x squared in every step. Obviously, there's something else going on because, 2 times 1 squared would be 2, and we've got 0 here. So here's what I'm going to do. I'm going to write a 2x squared for each step. So let's get our steps again. 1, 2, 3, 4. So 2x squared. So 2 times 1 squared, that'd be 2. How do I get to 0? Well, I have to subtract 2. And this is the part we're going to look at to see if we can find some pattern in what we're doing to this 2x squared each time. In step 2, 2 times 2 squared. 2 squared is 4, times 2 is 8. And I've got 4, so I'd have to subtract 4. How about in step 3? So 2 times 3 squared, so 3 squared is 9, 18. To get to 12, we'd have to subtract 6. I think I'm seeing a pattern here. In step 4, we would have 2 times 4 squared. So 4 squared is 16, times 2 is 32. To get down to 24, we'd have to subtract 8. So this is going up. The amount that's being subtracted is going up. Well, it's actually 2 times the step number, right? So 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. So this is actually minus 2 times the step number. And that, I think, is our equation. You can go back and plug these step numbers in here and see if it works for you, but I'm satisfied from this chart that this equation reflects the numbers that we've got. So y equals 2x squared minus 2x. Okay, so now to calculate the number in step 43, we would multiply 43 squared by 2 and then subtract 2 times 43. And let's see, 43 squared is 1849. You multiply that by 2, you get 3698. And let's see, 2 times 43 is 86, so minus 86. So what you're going to get here is 3612. So 3,612 pieces that the circle is cut into. Those would be some pretty small pieces. Well, how did that go for you? Did you get 24 for step 4, or did you interpret this pattern a little differently? Do you think we needed to have another visual here to differentiate it from some other possible pattern? Let me know. Thanks, everybody.